Hello, everybody, and welcome to lesson 6.5. Today we are talking about arc length. This is a BC topic only. So if you're in the AB class, you do not need to watch this, but it might be a good thing for you to watch to get a better understanding of calculus in general. So let's get cooking talking about arc length. So arc length is basically saying, let's find how long a curve is in the coordinate plane. So the actual length right here of this curve. So the question is, how would I do this? So before I actually do it, let's just say, well, how would I estimate it? So I can estimate it by cutting this into pieces and then just drawing a whole bunch of lines and adding up the length of all of those lines. So for each one of these little segments, the length of each one of these little segments would be delta x squared plus delta y squared, where delta x is b minus a, the endpoint minus the beginning point, and delta y is f of b minus f of a. So this is how I would find the length of each little individual segment. Well, if this thing is continuous, so if this function is continuous, then by the mean value theorem, there has to be some point C within that interval a to b, where f of b minus f of a equals f prime of c times b minus a, which is helpful because f of b minus f of a right here, this is delta y, b minus a, this is delta x. So then delta y equals f prime c of b minus a. So then delta y would be equal to f prime of c times delta x. And now I can substitute this in for delta y in my distance equation, and I get this right here. Delta x squared plus f prime of c squared, delta x squared, and then we're square root the whole thing. If I notice right here, I can factor delta x squared out of both of these. And then if I square root that, I'm left with just delta x times the square root of 1 plus f prime of c squared. So for each little subinterval, I could write it like this. And as these intervals get smaller and smaller and smaller, remember my goal is to add up an infinite number of these. As these intervals get smaller and smaller and smaller, I'm going to approach an infinite number of little lines right here. This delta x is my dx, and then this would just be the integral from a to b of the square root of 1 plus dy over dx, whatever the derivative is, squared. So this is how we find arc length. So we've got arc length is equal to the integral of ds, where ds is either the square root of 1 plus dy over dx squared or the square root of 1 plus dx over dy squared. It's going to depend on if it's in terms of x or if it's in terms of y. So if it's in terms of x, you're going to use dx. If it's in terms of y, you're going to use dy. So let's take a look at an example. So here's an example. I've got x equals 2/3, y minus 1 to the 3/2. I want to figure out the arc length between 1 and 4. So this is going to be the integral from 1 to 4 of the square root of 1 plus, now here's where I'm going to have to find dx over dy. So this is going to be dx over dy. So the integral right here, this would be 3/2 times 2/3, which is 1, times y minus 1 to the 1/2. So then I need to actually square this. So this is going to be dx over dy squared. Notice this is not the same thing as the second derivative. It is literally taking the derivative and squaring it, and that's just y minus 1. 1 plus y minus 1 dy. So this is the integral from 1 to 4 of the square root of y. And actually, just to make the power rule a little bit easier, or sorry, undoing the power rule a little bit easier, I'm going to write this as y to the 1/2 dy, because remember, square root is just raising the 1/2 power. So now when I take the integral, so this is going to be 2/3 y to the 3/2. I'm going to evaluate that between 1 and 4. So this is going to be 2/3 times 4 to the 3/2. Square root of 4 is 2. Cubed is 8. So this is going to be 2/3 times 8 minus 2/3. So this is going to be 16/3 minus 2/3. So this would be 14/3. So this tells me that the length of this arc between 1 and 4 is 14/3. So that is it for today. Today we talked about defining the integral for arc length, why it works, and then we did an example of finding the arc length. I hope you took some good notes, and I hope to see you in class, and I hope you have a fantastic day. I'll see you in the next video.